Hi students, it's Mrs. Gifford, and today we are going to do 4-4, proving triangles congruent by side, 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 and side angle side. So after this lesson, you'll be able to use the SSS and the SAS postulates to test for triangle congruence. First, here's one vocabulary term. It's an included angle, and it's an angle formed by two adjacent sides of a polygon. So if I had a pentagon here, this angle right here with the green would be considered an included angle because it's made up of those two adjacent sides of a polygon. So let's take a look at our two postulates for today. The first one is side, 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 and it basically says this: if the three sides of one triangle are congruent to three sides of another, then we can prove that those triangles are congruent. And then the second one is side angle side, which says if two sides in the included angle of one triangle are congruent to two sides in an included angle of another triangle, then we know that those two triangles are congruent. So let's do two examples. Here's the first one. So this is given. QRS is isosceles with QR being congruent to SR, and RT bisects QS at point T. We're going to prove triangle QRT is congruent to triangle SRT. So again, I'm given QRS is isosceles with QR congruent to SR, and we also know that RT bisects QS at T, and we are going to prove triangle QRT is congruent to triangle SRT. So here's my proof. The first thing that I'm going to do is start with what's given. So again, we know that triangle QRS is isosceles with QR being congruent to SR. And my reason for that is that it's given. Okay, the other thing that's given is RT bisects QS at T. Step 3, T is the midpoint of QS, and that comes from the definition of a segment bisector. Step 4, I can say that QT is congruent to ST based on the midpoint theorem. I know RT is congruent to RT, and we can say that that's reflexive. Okay. So then what we can say is triangle QRT is congruent to triangle QRS by the side, side, side postulate. And where are those three sides that we're talking about? We know that QR is the same as SR, so that's one of our sides. Okay? And we know that QT is congruent to ST because of the midpoint theorem. And RT is RT, that's right here from the one that they have matching. Okay, so that's using side, side, side. Now, our second example, we have the wings of a glider. The hang glider shown appear to be congruent triangles. If FG is congruent to GH and JG bisects FGH, prove that FGJ and HGJ are congruent. So again, if you want to pause real quick and set up your two-column proof. So the first thing I'm going to do is list what's given. So we know FG is congruent to GH. We know that JG bisects angle FGH, and we are going to prove that FGJ is is congruent to triangle HGJ. So we're going to use side angle side, just to give you a heads up with that. All right, so the first thing we know that's given, there's two things. We know FG, whoops, that's not it. We know that FG is congruent to GH, and we know that JG bisects angle FGH. So those two things are given. Then in step 2, we can say angle FGJ is congruent to angle HGJ. And why do we know that? Because definition of an angle bisector. And we have GJ is congruent to GJ. Very similar to the first proof that we did. It's the reflexive property. And then therefore we can say triangle FGJ is congruent to triangle HGJ, again by the side angle side postulate. Now where are those side angle side part? The first one comes up here with what's given. FG is congruent to GH. FG is congruent to GH is here. Our angle FGJ is congruent to HGJ. So here's FGJ is congruent to HGJ. That's right here. Okay, and then we know that GJ is congruent to GJ. That's this middle piece. So that's why we can say, based on the side angle side postulate, those two triangles are congruent. Happy proving!